How are we doing, guys? Looking at some constructions today. Drawing. So you're going to need your instruments. That is your set squares, your protractor, your ruler, your compass. Okay, so if you can get those things before you start. We're going to start looking at corresponding angles on parallel lines. So how do you draw two parallel lines? Well, you take one of your set squares and you just take one of your set squares and draw a line. Okay, and you want to draw a second line now that's parallel to that. So what you do is you take any ruler or straight edge or anything and you back it up against the other side of your set square. You slide that upwards. Now I'm after moving. Let's try that again. Slide that upwards, stop, and now if you draw a line up here, those two lines we've drawn are parallel lines. Okay, to show they're parallel lines, you put a little arrow along the way. And if we're talking about corresponding angles on parallel lines, well, if you put a line through here at any angle you like, now you will get different answers to me, which is absolutely fine. And I want you to draw this into your copy, but you won't get exactly the same answer as me. This angle here, okay, I've drawn it pretty close to 60 degrees there. In fact, oh yeah, it's about 59 degrees. Okay, so that's this angle here, 59 degrees. Okay, so you just put the crosshair down, and then this angle here is its corresponding angle. So I want to show that it's 59 degrees as well. So you put the crosshair down, that's the crosshair there, over the angle. Then you make sure that that zero line is lined up with your line. And now you can measure along here. Okay, so my zero is lined up, my crosshair is in, you can see there just shy of 60 again, so about 59 degrees again. Okay, so one of the things that we know is that corresponding angles are equal, and you should have just gotten the same size. Now you won't have gotten 59 degrees, but you should have got the same answer in both of those. Okay, so that's these corresponding angles. The next thing I want to show you is alternate angles. So that's, if you look, you get this kind of Z shape. I know that's backwards in your parallel lines, but this angle here and this angle here are called alternate angles, and they should be the same size as well. So let's have a look. I have to measure this one upside down, put the crosshair down there, line up my zero, and come along here. Okay, now there it is, 10, 20, 30, 40, 50, 60, just shy of 60, 59 degrees. The obtuse scale, 180, 170, 160, that's only for obtuse angles. Okay, so let me show you what I mean by that. First of all, we've measured 59 degrees, so put that in there. The other reading we would have gotten is this obtuse angle here. So we're working with the acute angle, which is 59 degrees. The other reading here would have been 90, 100, 110, 120, and a bit over 121. Okay. And 121 there is the obtuse angle, but we were interested in the 59 degree angle, so we used the acute scale. So these two angles here are alternate angles. They're the same size. A few other things to point out: 59 and 59, those are vertically opposite angles, so they're the same size. 59 and 120, well, that adds up to a straight line, and that'll add up to 180 degrees. And the last thing I want to point out is this 121 here and this 59 here add up together to 180 as well. Those are called interior angles. So I'll just write that up here. Interior angles on parallel lines, and they add up to 180 as well. Okay, so you should have that same drawing, but different sized angles, but you should be able to say, yes, my corresponding angles are equal, yes, my alternated angles are equal, and my interior angles add up to 180. Okay, next is a equilateral triangle. Equilateral means same, lateral side. So this is one where all three sides are the same length. I've got two X's marked on the page here, and they are 5 centimeters apart. To get the third side that's 5 centimeters from both of those, you take your compass and you make sure your compass is that same 5 centimeters. Okay, so you can see there I've measured against my two x's, 5 centimeters. Okay, and then sticking the needle down here, I'm going to mark an arc, and stick the needle down here, mark an arc as well. And where they intersect, that point there is 5 centimeters away from here, okay, because the radius of that arc is 5 centimeters, and 5 centimeters away from here. Okay, what we know about equilateral triangles is that all three angles should be 60 degrees. Now you might not know this, but this set square here is called your 60-30 set square, and this one here is called your 45-45 set square. They both have a 90-degree angle, but this angle here is a 60-degree angle. So you can actually use that to check, yeah, I've got a 60-degree angle there. Check in here, I've got a 60-degree angle there, I do. And check here, I've got a 60-degree angle there. Okay, if you prefer to use your protractor, you're welcome to use your protractor. Line that up along 0 there. There's my crosshair, and look, 60 degrees there. In an equilateral triangle, all three angles are 60. If you want to show that these are the same length, you just put a line through them. That means those three lines are the same length. In an isosceles triangle, okay, so what you want to do first in your copy is mark that little X. The reason that's there is you're then going to take your compass. I've done this already and I shouldn't have maybe. Okay, and you're going to mark a little arc from that X. Okay, but you need to know where you started, because an isosceles triangle is one that has two sides of the same length. So it doesn't matter where I draw this line and this line. These are both radiuses of my arc. Okay, so here's the triangle I have here, where I can say these two sides are the same length. So that's that little double line means, same as the single line over here, it means those two lines are the same length. Well, we know that if we have two equal sides, we should also have two equal angles. So let's just check that. Okay, that angle there is acute, so it's on the acute scale here, which is inside 10, 20, 30, 40, 50, 60. Okay, so it's halfway between 60 and 70. You can see it there. That's actually 65, bang on. 1, 2, 3, 4, 5. Okay, so that's a 65-degree angle. And over here, this angle here, again, if we measure it on the acute scale here, which is now outside, 10, 20, 30, 40, 50, 60, halfway between 65 as well. Okay, so in an isosceles triangle, the two base angles is what that's called, are equal. Okay, they're both 65 for me. You should have a different answer to 65, but you should have gotten the same size for those two angles. Okay, our next theorem was about the exterior angle, which is this angle out here. If you draw a triangle and you just carry on along the base, this angle here is called the exterior angle. So for us, our exterior angle now, that's now an obtuse angle. So measuring along our obtuse scale out here, that's the kind of 140, not the 40, okay, greater than 90 degrees. And that looks just short of 140. Do you see it up here? 139. So that's a 139 degree angle. Then our theorem says that this is an interior angle and this is an interior angle. This is also an interior angle, but our theorem says the opposite interior angles should add up to 139. So let's check if that works. Okay, I'll measure this out. So that is 50, 55, 6, 7, 58 degrees. Okay, and up here, and sometimes it can be useful to just twist the page around to help you measure. This one is 80, no, yeah. Okay, 81 degrees. Now, when I turn that around, it's going to be the wrong way around, but anyway, 81 degrees. So 58 plus 81, if you add them together, you're going to get 139 degrees. No surprises there. By the way, if your answers are coming out right except for 1 degree. It's probably because you're measuring wrong, or maybe you haven't drawn them very well. Okay, next thing is drawing a parallelogram. So that's 2 sets of parallel lines. So let's come back to our set squares. Same trick as before for parallel lines. This line here, slide it up. Oh. Okay, you need to keep your hand steady on this second set square. Okay. So those are 2 parallel lines. Now my parallelogram is going to have also, I'm sorry, I'm just going to draw my arrows. Okay, I want that to be my other line on my parallelogram. So I need to turn that around, line up my set square here because I want to draw a line that's parallel to that line. So I'm going to slide this up like here, slide it all the way up to there, say. And now these 2 lines are also parallel. Okay, so this is a parallelogram. Okay, a few things about a parallelogram. Opposite sides are parallel. Well, we've just drawn that. Opposite sides are equal. So from here to here, oh, that's bang on 5 centimeters. And from here to here, 5 centimeters. Okay, here to here looks like 3.4 centimeters. And here to here, 3.4. Okay, again, you'll get different answers, but they should be, the opposite sides should be the same. Finally, the opposite angles are the same as well. So this angle here is 70 degrees. This is its opposite angle up here, so let's just measure that. 70 degrees. Okay, so opposite angles are equal in a parallelogram. Last thing, quadrilateral is any 4-sided shape. Okay, so just draw any random 4 lines that you like. Okay, and what we know about a quadrilateral is that the angles should all add up to 360. So let's see what we have here. This is an obtuse angle. So on the obtuse scale, 90, 100, 110, that is 111, 12, 13 degrees. Okay, this angle here is 70. That's an acute angle. And now, occasionally you'll have to do this to measure something properly. You just need to extend it, and you might want to do this with a pencil if you don't like how messy it looks, but you just extend the line so that you can read it on your protractor. So that goes up to there, 75, 76. Okay, my next angle over here is 77. Oh, that's an obtuse angle. Whoops. So I should have been reading off the obtuse scale. So that's 110, 15, 16, 117. Okay, so let's write that there, 117. And here, this angle here is 50, excuse me, that's acute, 51, 2, 3. Okay, and 53 and a half, but I'm going to go 50, I'll round up to 54. Okay, 54 degrees there. So, 117 plus 54 plus 76 plus 113. Well, what do I get if I add all of them together? 117, oh, plus 54 plus 76 plus 113, and that's 360 degrees. Okay, so if you could draw all of those into your copybook, please. Thank you.